For this video, we'll be talking about section 1.4, which is the distributive property. To start here, we have some vocabulary. So we have first the coefficient, is the numerical factor of a term. For example, that would be like 7x would be the whole term, 7 would be the coefficient. It's the number in front. Next, we have like terms. Are terms with the same variables, with corresponding variables having the same exponent. We will have an entire section where we talk about like terms, so I'm not going to give you any examples right now. Next, we have the expressions 6x plus 2x and 8x are called equivalent expressions because they represent the same value of any value of the variable. So in this example we have here, we have 6x plus 2x. If you actually added them together, that would be 8x. Therefore, those are equivalent to each other. They represent the same thing. And then the last vocab word we have here is an expression is in simplest form when it is replaced by an equivalent expression having no like terms or parentheses. So this right here is the key. If there are no like terms or parentheses, that's how you know it's in simplest form. So to dive into our first set of examples here, we are talking about the distributive property today. So this little key concept right here discusses the distributive property. If you remember, the number on the outside gets distributed or multiplied to everything on the inside. So if there's 2 terms on the inside, it gets multiplied to both of them. If there's 3 terms, it would get multiplied to all 3, so on and so forth. The other thing that I want to make clear too, the number can sometimes appear on the back side of the parentheses, so then it would still get distributed to everything on the inside of the parentheses. So looking at number 1 here, we have a 6 on the outside that needs to be distributed to x plus 2. So we're going to multiply 6 by x. 6 times x would just give us 6x. And then 6 times 2 would give us plus 12. Please note that it is a positive times a positive. That's why it's a plus 12 there. So that would be our final answer because 6x and 12 cannot be combined together. There are no parentheses. So that is our final answer. It's in simplest form. Next, we have number 2. We have a negative on the outside and front here. This is actually a -1. So then we're going to take that -1 and we're going to multiply it by everything on the inside. So we have -1 times x would give us a -1x or just -x. Then we have -1 times -5. 2 negatives would make a positive. So plus 1 times 5 would give us 5. That would be our final answer for this one. Then on number 3, we have a 7 on the outside, so we're going to multiply 7 by x, and we're going to get 7x. Then we have 7 times -8 would give us -56 or -56. That would be our final answer for that one. And then going on to number 4 here, we have -3 on the outside. Distribute that to a 2x. So now this x actually has a coefficient with it. So we do multiply the coefficients together. -3 times 2 would give us a -6. It still has the x with it. And then we have -3 times 9 would be a negative or -27. On number 5, we have this 4. It's on the back side though. Some people like to just completely get rid of it and move it back out to the front so that it looks like the ones that we've been doing the whole time. I don't personally care where you have the 4 as long as you remember that it does get distributed. So whether you distribute it from the front or if this 4 was still here, it still, no matter what, gets distributed to both terms on the inside. So 4 times 8x would give us 32. 4 times 8 is 32. X still goes with it. And then 4 times 11 would give us plus 44. You do have to have a sign in between the first term and the second term. So if it's positive, it would be a plus sign. If it's negative, it would be a minus sign. On number 6, again, we have the -5 on the backside. You'll notice it's actually also in parentheses. The reason it's in parentheses is if they wrote it as 10x minus 1 and then just put the -5 on the end like that, it would actually look like it's -5. This would not actually be part of the distributive property. We would not distribute on that one. So that's kind of why the parentheses are there. But again, like number 5, if you want to move the -5 out in front, you are more than welcome to. But we will go ahead and distribute it from the backside so that you have an example of both. So we have 10x times -5 would be -50x. And then -1 times -5, two negatives again make a positive. 1 times 5 would be +5. 3 more here. So on 7, we would have -4 times 5x would give us -20x. And then -4 times -6, two negatives make a positive. 4 times 6 is 24. On number 8, we have, again, a negative out in front that acts as a -1. So if we distribute the -1 to 11x, that would be -11x. Remember, distributing is multiplying. So the -1 times 1 would be a -1. On number 9, it looks a little bit different. We have 3 terms on the inside, so we just need to make sure that we distribute the -7 to all 3 terms on the inside of the parentheses. So if we start with the x, -7 times x would be -7x. -7 times 3y would be -21y, so we would have -21y. And then -7 times -z, two negatives make a positive. 7 times z would be 7z. And you will notice I do cross my z's so that they don't look like 2's on accident. You do not have to do that at all, but I just didn't want you to be confused as to what I wrote there. So that is a +7z. That is it for the front side of our notes. Let's go ahead and go over to the back side. So the first section on the back side, we want to talk about are each pair of terms like terms. If you remember from the front, like terms are terms with the same variables with corresponding variables having the exact same exponent. So on number 10, are these like terms? 7 has an a and -3 has an a. They have the exact same variable base. So yes, these are like terms. On number 11, 6 has an ab. -2 only has an a. So these are not like terms. They do not have the same variables or letters. So this would be no. On number 12, we have 4x squared and 12x squared. Both of the x's have the exponent of 2 with them. So that would make these like terms. And all we're doing here is writing yes or no. It says it in our directions right here. So we're just stating if they are like terms or not. So then on 13, 8 has no variables, and 15 also has no variables. So that would actually make these like terms. And then on 14, we have x cubed and x cubed. So far, so good. And then we also have a y and a y. So that would make these like terms. They have the exact same variable base. The exponent is in the same place on both of them. Now on 15, we have just an x and an x squared, and then we have a y squared and a y. The 2 moved on both of those variables, so these would not be like terms. Yes, they both have x's, yes, they both have y's, and yes, they have exponents of 2. However, the 2 is not the same in both places, so it is not like terms, or they are not like terms. Now, on 16 through 21, we're actually going to combine the like terms if we can. So if you remember, combining like terms, you just read it from left to right and you do exactly what it says. So on 16, we have 3x minus an x by itself is really a 1x. So then these are both like terms because they both have an x. So then 3 minus 1 would give us 2, and the variable stays the same as x. So then that answer would be 2x. 17, we have y squared and y squared, so these are like terms. So again, we read it from left to right. 4 plus 2 would be 6, and then y squared stays the same. The variable base stays the same. On 18, I see lots of different things here. So I see that the first term here is an x. So then I'm going to find the other x that has it in common, and we're going to do 2 minus 4. So again, I'm ignoring all the other things. 2 minus 4 would be -2. The x stays the same. But then we have to also focus on, this has a y squared, but this only has a y. So those are not like terms. They would just get rewritten next to the -2x. So then I would just bring down the 4 y squared, sorry, plus 4y squared, and then I would bring down the other plus y. This would be our final answer. Yes, there are multiple terms in our answer, but none of those are like terms anymore. So that would be in simplest form. If you remember from the front, simplest form is when it's replaced by an equivalent expression having no like terms or parentheses. So at this point in this answer, there are no more like terms. On 19, we have an xy and an xy. So an x with no exponent, a y with no exponent on both of those terms. So these would be like terms. This again, xy by itself is really a 1xy. So we have -7 plus 1 would give us a -6. The variable base stays the same as xy. On 20, I see an x squared, an x, and no variable. So none of these are like terms. If you notice right here, it says if it's not possible to combine the like terms or simplify the expression, we're just going to go ahead and say it is simplified. Some people get confused because they see that this has an x and this also has an x, but remember, this 2 here makes both of these not the same. And then on 21 here, we have 1y minus 23y. Those would be like terms. They both have a y. So 1 minus 23 would be -22y. Remember, combining like terms, you always, always, always go from left to right. You do exactly what it says. Now, on the last 3 here, the next 3, we're going to take the 2 ideas that we've learned today so far, and we're going to combine them all together. So we're going to simplify each expression using the distributive property first. And then if we can, we're going to combine like terms. So looking at number 22, I see 5 plus 3 times x minus 7. If you remember PEMDAS, if I write that over here off to the side, a lot of people always think, well, parentheses are first, right? But inside the parentheses, there's nothing to do. So we're going to skip over parentheses. There's no exponents. Notice right here, multiplying happens before you add or subtract. Adding or subtracting would be combining like terms. Multiplying would be your distributive property. So distributing always happens first, then you combine like terms. Never, ever, ever add the 5 plus 3 first. So we're going to ignore the 5. We're just going to bring it down for right now. And then we have this positive 3 that we are distributing to the parentheses. So we have 3 times x would give us a plus 3x, and then 3 times -7 would give us a minus 21. Then the next thing we have to do is combine any like terms that we can. So I like to put my variable term first. So I see that there's only a 3x. I'm going to go ahead and bring it down. And then I see that there's a 5 and a -21 that can be combined. You'll notice I underlined those twice to insinuate that they are like terms. So if we have 5 minus 21, that would be minus 16 when you combine those like terms. On 23, I see that we have 2 sets of parentheses, so we're actually going to have to distribute twice. So -2 times 3x would be -6x. -2 times 4 would give us -8. Then we have a second set of parentheses. This is a -1 being distributed, so -1 times x would be -x. -1 times -7 would give us +7. Then we have to combine our like terms. So again, I like to do the variable first. -6x and -x would make -7x, and then -8 and +7 would end up making that a -1 when you combine those. On 24, it's very similar to 23, so we're going to distribute the 7 to 2x and to y, but notice the parentheses end. I didn't really stress this on 23. The parentheses end after the y, so the 7 doesn't get distributed to everything, just the parentheses it's next to. So 7 times 2x would be 14x, 7 times y would be plus 7y, and then we have 6, and it's a positive 6, times x would be plus 6x, 6 times 5y would be plus 30y. Last thing to do here would be to combine your like terms. So 14x and 6x would make 20x, and then 7y and 30y would make plus 37y. Okay, and then on 25, we have a little bit of a word problem here. So you'll notice the first thing that they want us to do is write an algebraic expression to represent the verbal expression. So we've been doing this for a little bit now. 3 times the sum of, remember of and imply parentheses here. So we have 3 times the sum of 2x Sum means plus, so we're going to put 2x plus 3y. Then that parenthesis ends. And then it's decreased by, so that means minus, twice the difference of 4x and y. Again, I see another of and, so that means parentheses around those. So twice would mean times 2, and then difference means subtraction, so 4x minus y. Now that we have part A done, we actually have to simplify the expression. So we're going to take 3 times 2x and make that 6x. 3 times 3y would be plus 9y. And then we have negative 2 being distributed. Don't forget, you have to pay attention to the sign in front of the number in front of the parentheses. So negative 2 times 4x would be minus 8x. And then negative 2 times negative y. 2 negatives make a positive. 2 times y would be 2y. Last step here, combine your like terms. 6x minus 8x. 6 minus 8 would be negative 2x. And then we have 9y plus 2y would give us plus 11y. That is it for these notes.